I'd like to come back to this question of data analytics versus data science and unpack some of the differences between these two roles so that you can figure out which of these two roles you need to drive your objectives. First of all, data analytics. The key here is the core output for data analytics is a report or a research study, some tangible analytical output that's going in front of a person. This is the key. A stakeholder, an executive, a product owner who has decisions to make uses these analytical outputs to inform that decision. So it's critical that there's a very close relationship and understanding between the business objectives and the analyst's work. The analyst is essentially intermediating between open questions on products or businesses and the data set. The analyst has to structure analysis, choose specific data attributes, figure out how to optimally present this information, and, if possible, overlay a narrative to make it clear and fit it into the decisions that are being made. I think analytics is probably as old as business itself. Of course, now data sets are larger, way more data, and different tools, different methods to analyze the data. But the basic function is probably as old as stone tablets. We just have to make sure that we have someone who's got the expertise to use the data and to access big data. It has its own complexities. But the key is this tangible output that is really meant to drive a specific set of decisions forward. On the other side, data science. Data scientists do produce reports and research studies, but usually as intermediary products. If they're working towards building a predictive model, machine learning models, AI models, these terms are used interchangeably. Different companies will term them differently, but the key is there's a model that's making decisions based on data in production. So within a software stack or on an e-commerce site, instead of a person looking at analytical outputs and forming some decisions based on that or using the analytical work to make a decision, the ML model takes over that responsibility and is making the decision for the person. There's not a person making the decision at runtime, it's a model doing it. This is the core output of a data scientist. The cases where this is especially relevant are cases where you need scale. So simple example would be an e-commerce site. A customer or prospect comes into the site and there's ML models figuring out what merchandise to show to that particular customer. It wouldn't be practical to have a person executing all these small decisions, millions of customers coming into a site per day. ML model can do that at scale. There's a few questions you need to really consider with data science. First of all, do you need this kind of scale? Are you making this many decisions at runtime? Second of all, are the decisions that a recommendation model would make, are they substantially better or even incrementally better than basic conditional logic? So you want to be able to test these things side by side. If you're building data science models, you want to have a sort of a baseline. The conditional logic for what you're going to show or curate to a given customer versus the more powerful ML model. What's the incremental, and how does that incremental compare to the cost of building that model? Not just the cost of building it, but the cost of deploying it. This is the other very complicated piece of data science, is deployment. So with analytics, you're delivering an output to a stakeholder. So it's no technology to basically put a report on someone's desk. But with a model, it can be complicated to actually move it into production, put it into software, somehow have it triggered at runtime to make a decision. And that process can be very complicated. So when you're thinking about data science, think not just about the scale and the necessity to have a powerful model curating or doing anything, right, to inform any product decision in production, but also your ability to deploy this model into production and to maintain it in production and to have this whole pipeline functioning. That part is very complicated, and many organizations struggle with that piece in particular. They have data science models that are created for specific purposes, but then they are not able to really move them into production and have them maintain over time. These are some of the important considerations about data science. I wanted to quickly outline these two differences. In future videos, I'll talk more about how we can optimize these two different branches of work using inquiry frameworks, the Hockeyan inquiry framework. essential to guide the outputs of these two similar but different functions in a way where they're producing something that is actually needed and is going to make a fundamental difference in the product or business.